One, sorry for the technical problem because before we ask. Okay, cannot record. Cannot record. It's okay. All right. Before we ask Dr. Lina using Zoom, but I don't know. We have two invitation, Microsoft Team, and I cannot enter the Zoom. It's okay. I think we can start. Okay, my name Dr. Nur Elma binti Kordi. I representative Dr. Mazlina Zaira for this class. Okay. With us we have postgraduate students and undergraduate student will coming. Okay, I just admit them in while we'll start the class. Okay, with us Dr. Abhinesh Prabhakaran, right?
Yep.
Okay, so we have a speaker from University of the West of England, UWE, Bristol.
Yep.
So Dr. Abhinesh will talk about the use of immersive virtual reality for supporting mental health and well-being. Okay. Okay. Without further ado, I pass to the Dr. Abhinesh, please.
Yep. I'll share my screen, and if you can see my slides, are you able to see my slides?
Yes, perfect, Doctor.
Okay. Okay. Thank you, Nurel, for the intro. And good evening. I think it's good evening to all in Malaysia, and morning to Abdul in UK. So my name is Dr. Abhinesh Prabhakaran. I'm a lecturer in building information modeling at the University of West of England. And the topic I'm going to talk about today is something which is less explored, especially in the context of using immersive technology, is how immersive technology can be used to address oral presentation and public speaking fear in higher education, which could have a significant impact on the students or mental health and well-being. So it's going to be 30 minutes, somewhat around that time of presentation. I'll quickly go through some of the stuff we done in this project and then open the floor for questions. Before we get into the details of the project, so this was an internally funded project funded by University of the West of England as part of the UWE's Pedagogy Project 2024. The research team involved were myself, Professor Colin Booth, who is a professor in sustainable built environment, and also Professor Patrick Manu, who is also a co-investigator in this project, who is a professor in smart construction. So a bit of a background before we get into detail, so that you understand the context of why this research was important and the novelty of the tool we developed as part of this project. So I'm not sure how things work in Malaysia, but in the UK context, oral presentation and public speaking skills are important predictors of students' classroom success. Like I said, the relevance of these skills, particularly in the UK higher education context, cannot be overemphasized, because most of the modules in the UK uses presentation as a means of evaluating students' understanding of the subject and their ability to develop and deliver engaging and persuasive argument. So this also requires the students to prepare verbally, to participate verbally in both small and large group settings as a way to improve their learning experience. These fear could also have effect, these skills could, these interpersonal skills can also have a positive influence on a graduate's employability. However, studies indicate that a large proportion of students in the UK higher education experience a fear of oral presentation and public speaking, resulting in students missing out learning opportunities by avoiding interactions, leading to poor learning experience, which could in turn affect their grades and future job prospect. And crucially, the impact of this oral presentation and public speaking fear could also associate to anxieties, which goes well beyond any academic achievements we were talking about. So this persistent fear of public speaking can contribute to broader mental health challenges, including elevated stress, low self-esteem, feelings of inadequacy, or even symptoms of anxiety and depression. For some students, this fear can also influence their fundamental decision about taking part in higher education. Um, so um, this oral presentation fear has got a bit broader context of impact, not just in the academic side of it, but also in the mental health and well-being for a student. So this is the context where we thought about um, um, the how can we address that. But beyond academics and all the mental health and well-being issues we spoke about now, um, the the once once a student graduates, this fear could have a significant impact on their employability as well. Because as you can see from the picture here, oral communication and presentation skills are some of the top skills employers look for when recruiting graduates. And in the UK, specifically, studies indicate that a significant number of graduates um, uh, do not apply for jobs which requires these kind of skills. And these days, most of the jobs require some form of presentation or public speaking in it while you are in the job. So that also affects their future job prospect, where they tend not to apply to those kind of jobs. And it could also, whilst you are in the job, it could also affect your future career progression, where managerial positions such as requires these skills as as one of the topmost skills. So as graduates tend not to apply for those as well. Um, and education experts and employers equally agree that graduates enter the job market with significant gap in these skills, and that higher education should be doing much more effective in training them in this sense. So this is where we put all this together to look at how can we help students overcome this fear, ultimately helping them to have a better mental health and well-being. So what we proposed was to develop a tool, a virtual reality based tool called Stagecraft, that provides students with an immersive environment for the students to practice their presentation, and importantly, a place which is much safer for the students, where they are not being judged based on any of their performance. So Stagecraft combines VR, which is a virtual reality, artificial intelligence, and eye tracking to simulate real life presentation scenarios, and to provide students with real-time feedback on aspects such as their tone, voice, eye contact, audience, etc. Stagecraft is a highly customizable virtual environment. For example, students can choose the number of virtual audience. These all will make more sense when I get to the video where I'll show you what I mean by virtual audience, etc. Uh, but it like I said, it is a highly flexible tool or a customizable tool which allows the audience, the students to select the type of classroom they want to practice their presentation, the number of virtual audience they want to. They can set the level of distraction in the classroom, like simulating like real life situations. And importantly, they can also get feedback based on their presentation. And like I said, the classrooms they can select, all the classrooms we have within the Stagecraft is a virtual representation of physical classrooms in UV. So they represent realistic classrooms, which even give them a sense of being in on UV campus, one of the classrooms. So that is also a key feature which makes it more realistic and more effective for the students. Another feature is the AI element that, like I said, in real life, while once you finish your presentation, you are faced with questions from the audience. So we simulate this in Stagecraft by using artificial intelligence, basically OpenAI. which asks, the virtual audience will ask you questions which are dynamically generated based on your presentation topic. And then these questions are being asked at you once you finish your presentation, which means a tool is not just a tool to practice your skills, but also to prepare you to real world situations where you have to face difficult questions. Now, another feature if you have used VR in the past, you know that uh, virtual reality tend to be a single user experience where once you put the headset, you're completely blind and you're just by yourself within the virtual environment. But Stagecraft is a multi-user tool, which means up to 20 students can join the presentation at the same time, which means if a student or a group wants to practice their group presentation for group works, they can use Stagecraft. But also if it's a single user presentation, but still they want their peer to be present there to give them feedback or to support them, they can also join the space remotely from anywhere, just need to have an internet connection and a virtual reality headsets. Okay, so just a bit brief on the methodology we used to develop this. So we had basically 3 phases in our research. The first phase was where we looked at what is the prevalence and impact of oral presentation and public speaking anxiety in higher education. We looked at the literatures to see how big of a problem this is, and that informed us that even though there is quite a limited number of literatures in this area, all the literatures which we identified showed there is a significant problem in the higher education globally. And we looked at UK specific, and there is also evidence suggesting that in the UK also it's a bigger problem, like 56%, or I think more than 80% of the students had that fear from studies from the UK we found. So then our next step was in phase 1 to see if VR have been used specifically in this context to address oral presentation fear, which we know that there have been some applications in the past which is developed as a commercial product, but there is no much research which indicate VR have been used as a tool to address this specific challenge. But we also know that VR have been used widely in addressing various other kind of anxiety treatments like hydrophobia or fear of height or fear of spiders. Treating all those kind of phobias, VR have been shown a very good outcome from those research. So we had every reasons to think about why not we use VR, because it has got all the capabilities to simulate real life situations and real life conditions, which can make believe the users and can deliver the same kind of experience we are expecting from a real life presentation situation. Okay, so that informed us to go further on developing the VR tool, in which we did the development in technical development in phase 2, where we first captured the classrooms, because as I mentioned, probably in the next slide I'll show you a more detailed version of that workflow. But as I mentioned, all the classrooms in Stagecraft is a virtual representation of real life or physical classrooms in UV. So we wanted to make it as much real as possible to the physical representation. So we used a kind of certain technologies and workflows to get the physical classrooms into virtual environment by using like scanners and things, which I'll show you in the next slide how that workflow is. And once we have got all the virtual elements and classrooms set up in the VR environment, then we integrated the OpenAI, then Amazon's web service, which is basically helping us in this tool to convert the text to speech and speech to text. Then we also did the eye tracking or the head movement integration as well in the application, and the product was finally delivered. Then it's beyond developing the tool, we want to also measure the impact, right? If we can't measure the impact, then we cannot say whether the tool was successful in achieving the aim of our study. So in phase 3 was basically going through the testing, which is also an ongoing process now, because you cannot test it, you cannot complete this kind of testing in a very short period of time. We used a one group kind of pre-test, post-test design where we measured students fear of or public speaking or oral presentation fear, using anxiety testing questionnaires to understand what is the current state. And then the treatment, which is the stagecraft application, was the tool was given to them to use for a period of time like three to 4 months, which means they can take virtual reality headsets on loan from our campus. They can take it to home. They can install the stagecraft software in the headset, and then practice their upcoming presentations, like their assessments, group presentation, etc. And then after 3 to 4 months period, we do the post-test to see whether there was significant improvement in their pre-test results compared to the post-test. And we also looked at the usability and user experience, because if the user experience and usability are not great, then the perception or the users' intention to use these tools will be very limited. So those feedbacks are then put back into phase 2 to enhance the tool. So like I said, the post-test is ongoing, which is a long process. I hope to update you with some results later on with that. So this is the workflow I was mentioning about. How did we get the virtual classrooms into, sorry, physical classrooms into virtual environment? So we used a combination. So the initial process was to use Matterporter, which is a photogrammetry based scanning tool. We scanned UV classrooms, the classrooms which we required for this pilot project. And then we used a combination of Blender, which is a gaming modeling environment, plus Revit, because some of the informations about the classrooms were already available in our digital campus archive. So we combined it with all the scanning data, then pushed it into Unity, which is a virtual environment development game engine platform. And then that has been used to create the virtual environment as you see in this screen. I also want to show you a comparison between how the actual classrooms in UV look like, which is this one, and the virtual representation of those classrooms are shown here using the process of scanning and then pushing them into VR. Now, a bit about the tools interface itself. So when you put on the headsets, you are presented with options like audience. So you can use your headset to select the number of audience you want to be in the classroom. For example, you can set it to 100 to have a full classroom. You can set the distraction level. You can keep it to 0% where you will be in a very quiet classroom, or to 100 where you will be in a very noisy classroom. So it's basically allowing you to prepare for all kind of scenarios normally you face in a presentation environment. The second aspect is the OpenAI feature, where if you're going to talk about a topic and you know these are going to be the theme in your presentation, then you enter those keywords in this keyword area, and then you can set the number of questions to be asked at the end, which means OpenAI picks these keywords, generates the question, and then based on the number of questions you selected, it asks those number of questions through your virtual audience, which I'll show you in the next slides how they ask. Okay, and then you have in the other screen, which is the room selection tool. Room selection, basically as this is a pilot project and the funding is not big, we had to stick to 5 classrooms of different seating capacities. So you can see a seating of like lower seating capacities like 37 all the way up to 353 seating capacities, and different types of classrooms we have scanned to create a different scenarios based on how the student want to practice. And also you will see an interface at the bottom, which is the multiplayer settings, where if you want to go as a group presentation practice, then you can use this interface to select the avatar you want to be represented within the virtual environment and then join the room. So these are some of the screenshots from the tool itself. What you're seeing here, this one is the classroom the student picked. So what you're seeing is all in virtual environment. So the classroom is numbered as 2x112. That's how it is numbered in UV. At the bottom, what you're seeing here are the feedback. So as I said, at the end of the presentation, students are given feedback. So you're seeing patches of blue, red, and green, which means they are heat maps showing your engagement with the audience while you're presenting. So sometimes when you are new to a presentation, when you are scared of presentation, you have that anxiety in you, you tend to only look at the monitor or your script and then just read through those slides and not even engaging with the audience or having eye contact with the audience. What this heat map is basically telling to the student is this is where you were looking and this is the time you spend looking at this place. You didn't look at this area or how you can improve engaging with the audience. So that is a kind of feedback that helps students to focus on, not to focus on just on their slides and then just read through it, but to engage with the audience so that the presentation itself is more engaging and interesting for the audience itself. This first slide, this first one you're seeing here is the score that is being presented to the student. Basically, that score is telling students how many filler words they used. You might know this, like if you are in a panic situation, you always use a lot of filler words like ooh, ah, kind of tones and things. So the scoring system, basically the AI system counts those filler words and give you a speech report, which you see in the second slide at the bottom, like a filler word report, and telling you how good were you presenting. So this is how the questions are generated once the presentation is finished. So you see here, the topic I think I entered while doing this demo was AI, BIM, and VR. So AI just developed a question based on those themes, and that question is being verbalized to the presenter through the virtual audience. So the question AI is asking, how are advancements in AI impacting the integration of BIM platform with other technologies such as VR and AR? So these are the kind of really realistic questions dynamically generated each time when the student practices, and then they have to answer those questions based on their understanding about the subject. I'm quite aware of the time, but I'll just quickly show you a quick demo of the tool, how it looks like when you put on the headsets. These are the interfaces you saw in the previous slides. So you can use your sliders to set the audience level like that. You can scroll it up or down. Then you can select the classroom, which type of classroom you want to go in. And so you can select it from that drop-down list, as you can see in the top. Once you have selected, you can select the keywords you want to enter so that the questions will be generated based on that keyword. So you enter the keyword using this keyboard. And then once you say start presentation, you get into the room, you see all the virtual audience. Your slides are already loaded. You can load it to your device, then use your controller as a clicker like you do in real life presentations. Then click through the slides. It changes as you click on the controller. So you can go through each of your slides, present like as if you're presenting in your real life. And then at the end of the presentation, you can see those white boxes there. And those are the people who have got questions to ask you based on what you have presented. And at the end of the presentation, once you have answered all the questions, you get the feedback report, as you can see here. So what you're seeing here is the speech report, the final score based on your presentation, number of filler words used, etc. And you can also look at this heat map. So what you're seeing here is on the right side. I didn't look at anybody in the right side. I was just focusing on few people in the center of the audience seating. In that way, I can improve my presentation engagement as well. So going forward a bit in terms of the testing. So like I said, it is an ongoing process. We are testing it internally with the programs which I teach. And then once we know that there is significant impact for the tool, we are planning to push it out to a wider testing group. So like I said, we used one group pre-test, post-test kind of design. And in the pre-test results clearly indicate that the research findings we found were quite right, because you can see a significant number of students have got extreme or high level of fear, public speaking fear, and very low number have got no fear at all. So that's the pre-test results. And then in terms of the usability evaluation, we got quite a positive results in terms of the usability. The students consider the environment as to be captivating and immersive, felt involved. So these are some of the factors which could significantly influence a user's intention to come back and use the tool again. So we can see some very high positive results in here, like agrees and some strongly agrees kind of maps, which tells the tool is quite a user-friendly and a useful tool for the students to practice their presentation. Also, we initially captured some through qualitative data, and we did some thematic analysis, and some of the responses from the students are like highly effective. They feel very safe. And this is a key element because most of the researchers indicate that this fear that stems from the sense of being judged and sense of being unsafe in a big, when you stand in front of a bigger audience. So students are feeling very safe within the virtual environment, and they definitely recommend. So you can see some of the key themes we identified from this thematic interview after the through the qualitative interview after students using the tool. And also there are some quotes I want to present here in terms of the qualitative comments they gave, like the immersive VR was truly transformative, realistic virtual environment. It increases the confidence levels significantly. Being an international student, it helped me to pace improving my pacing, audience engagement, etc. Some of the students were very interested in the AI generated questions, which particularly helped them to prepare for facing real life audience. Few others, like safe environment, like I said, students felt very safe with the tool. Heat maps and engagement with the audience were some of the key features. They found it useful. Simulated audience interaction. So these are some of the aspects we think is changing students' approach to presentation, and we're looking forward to get more results on how much of an impact it will have to in the longer run. Going forward, so like I said, we are going through the post-test design now, testing now, but also in terms of dissemination, we have got 3 journal articles in the pipeline. This particular project have won RISE Award 2024 for in the category of education and training. Also, we are looking not just to push this into higher education, but also to further education, because I've been in touch with some of the people in further education, and they tend to say students are more facing this sort of fear in further education as well. So we wanted to test it out to a wider audience as soon as we finish the post-testing with a smaller sample within our program. Also, we want to develop this tool further. At the moment, we have all these features, what you see on the right side, multi-user, eye tracking, Amazon's web service, OpenAI. But what we want to add new to the system is data collected from wearables and facial expressions. Basically, your smartwatch can give you a lot of information about your panic heartbeat, your saturation, your blood, etc. Can we use those informations to create dynamic VR environments which provides environment in a individual basis? Like if I am in a very panic mode while presenting, the system should sense it, and then the virtual environment should dynamically change to help the students to overcome them. So we are looking into developing this tool further in that direction as well, which will be a game changer in this field, we believe. And that's end of my presentation, and I hope you all enjoyed. And I don't know if you're going to ask questions now, or we're going to take it at the end of this 1 hour slot. Thank you all for listening.
Okay, thank you, Dr. Abhinesh, for the excellent presentation. Student, I think you want us what do we are?
Sorry?
I asked the student if there are any questions.
Yeah. So we'll wait for questions. Yeah.
Anyone? Anyone, students? Okay, I think I have one question, Abhinesh. Okay, is using VR for
Yeah.
mental health safe for everyone? Because
Yeah.
as we know that VR is part of the gadget, right?
Yeah.
While we know that while we are asleep also, we are not encouraged to put handphone beside or near us. So how about the VR? Is it safe for everyone?
So these headsets, what we're using are commercially available headsets, which the manufacturer itself says anybody over 13 can use it. But
Mm-hmm.
it also comes with basic safety requirements, like when you put a headset, you need to be clear on of areas where you don't trip or fall. So those kind of basic safety precautions need to be taken for anyway. But we are not proposing anything new in terms of the hardware. This has been used worldwide for gaming, and most of the youngsters or higher education students use these tools. So I'm not particularly worried about any safety concerns in that sense. Yeah, but there is basic safety, which when you buy the headsets, it comes with the headsets on how you should use the headsets responsibly.
Mm-hmm. Okay, thank you, Doctor. Any one more question? Or okay, they have in the chat box. Oh,
So I am not able
okay,
to
is
see
the
that.
software
Yeah.
one question? Is the
Yeah.
software gonna be available for free or there is will be subscription to use it?
So yeah, that's a good question. We are looking into commercialization of the tool, but we definitely need to finish our ongoing post test to see the tool is actually making difference in people's life. But in terms of the costing, because the OpenAI, as you probably know, that these all cost us to run. So there will, if at all we are commercializing it at some point, there will be a cost associated with it, but that will not be a major cost. We will look at something so that the model itself is sustainable for us to run and provide it to everybody. Yeah.
Okay, okay, thank you. I think we are right on time. Okay, thank you, Dr. Abhinesh.
Thank
Okay,
you. Thank you
so
all.
we have another session with Dr. Abdul-Majeed Mahamadu. Okay, Dr. Abdul-Majeed is from University College London, UCL. Okay, the topic is immersive technology development in safety management. Without further ado, please welcome to Dr. Abdul-Majeed.
Okay, thank you very much, Dr. Norrell. As you've already briefly introduced, I am Abdul, so I'm an associate professor at the University College London. We're based in London in the UK, and specifically I'm in the department that we call the Butler School of Sustainable Construction. So in our department, we generally focus on subjects in the built environment around project management, construction management, construction economics, as well as real estate and digitalization and its applications. And my role here includes being director of our integrated degree program in construction project management. But generally, my research is into the application of emerging technologies and immersive technologies being one of the key technologies that we've applied in research over the past, let's say, about 8 years. So my talk is going to be primarily about some experience using it. At least one of the application areas has been introduced by Abi in his lecture, but I would focus on some other application areas. It will be based on research that we have done, but also just some of my general views about the effectiveness of using these approaches. Okay, so I think if I manage to get my slides working. Okay, I think it is. Abby took us through an application of immersive technology, one particular aspect of it, which is virtual reality. But over here, I'm going to take us a few steps back just to give us broad general definitions, especially for the benefit of those who this might be new to. I'm guessing that VR is no longer that new, but then just for us to have a foundation. So what is immersive technologies? So immersive technologies generally help us in creating simulated virtual environments, okay? And sometimes we could merge those virtual environments with the physical environment. Other times we could have only the virtual environment that looks a bit like a physical environment. So the fact that this is a simulation means that we can simulate different types of experiences artificially in order to achieve a certain goal. For example, like in Abhinesh lecture, demonstrating a tool that's used in actually training people about presentation when they're actually not in a real presentation scenario. So that's basically what immersive technologies are. There are a number of types that we'll look at in the next couple of slides, but increasingly, it's being used not only to generate visuals, but also other forms of simulated experience. So, for example, sound and even sometimes touch or even smell. So that's not a very well developed area, but it's also emerging. So basically, it's being able to generate or simulate an artificial environment within which you can do different things. So if you see the images on my slide, you'd realize an example of virtual reality, which normally depends on head-mounted displays. On the right, you would see a person with virtual reality headset, and on the left, you would see what they are actually seeing in the virtual space. So you can see it's a completely simulated environment, different from the actual environment that they are standing in. So these are the different types. So we've got, if you look at the left of the continuum, you've got the physical world. And if you move to the far right, you've got virtual reality. So physical world is us just seeing the natural environment in 3 dimensions, and the virtual reality is us completely being immersed in an artificial simulated environment. But in between, we have other technologies, for example, augmented reality as well as mixed reality. So augmented reality is where you have a virtual simulation which is overlaid on a natural physical environment, whereas mixed reality is also a combination of both natural environment as well as virtual simulated environments in a way that both of them are quite blended. So all of these have their applications and benefits, but generally they have an element of simulating virtual environments through using some digital tools. So those are examples of devices. So virtual reality would normally be based on head-mounted displays that cover completely your eyes, whereas augmented reality could be operated on simple devices like smartphones or even tablets. And mixed reality also would normally also be based on head-mounted displays. There are other types of displays, but today's presentation, this is just kind of introducing you quickly to some of the different aspects of immersive technologies. So we wouldn't go into the details of all of the others. So why is this an important thing? Why is generating immersive virtual environments useful? So we already display 3D information. So someone would say, for example, building information modeling or other audiovisual display systems already provide 3D virtual simulated environments. So what's special about these immersive technologies like VR? So they've got 2 main advantages that looking at 3D information on 2D screens doesn't provide. So they've got what we call the sense of presence as well as realism. So presence being the ability for a user to feel they are actually inside the virtual location. And realism is how close the virtual experience is to a real world experience. So this happens because, according to research, immersive simulation stimulates aspects of our sensory system in a similar way as we view things in the real world. Okay, so if you have a 3D image on your computer screen or your TV screen, you're still looking at a 2D interface. So it's not the exact thing as if you would see it in natural world or life. However, with immersive virtual reality, the technology is such that it uses Copic approaches to displaying the information, so that the information is displayed to you in a more similar way as you see in real life. So this image on the screen are brain scans of a virtual or immersive driving simulation. Okay, so these were experiments to see how virtual reality actually acts on our senses. And it was realized that when people are in a virtual environment, it actually activates parts of your brain in a very similar way as when you are in the real world. So it works better than pictures on paper, 3D pictures on paper, or on screens, which is 2D. So it's not as realistic. So you don't have presence and realism. But with these immersive experiences, the way it acts on your brain is that it's slightly more realistic in terms of the image you're seeing. So that kind of shows you a bit of an example. If some of you have used virtual reality or played games, you'd realize that sometimes when you put it on, it can feel quite real, just as this old lady is feeling. So this is why virtual reality is slightly different from all of the other things that we know. So how can we apply this technology, which we believe is more realistic in terms of visualizing virtual environments? How can we apply it to construction, specifically the management of safety in construction? So an example is safety training. Okay, so rather than exposing workers to real risk or hazards on site in order to train them, you can actually simulate those risks in a virtual environment. So at the end of the day, it wouldn't hurt them if they actually take the wrong decision in the virtual environment. So you can completely simulate how construction is going to take place and use that as a basis for training. The advantage of this to standard training approaches is that you can generate a virtual environment that's very similar to where the individuals are going to work based on exact site conditions. These could be used also in helping with emergency preparedness. So that could be even for existing buildings, teaching people how to evacuate the building in the event of an incident, for example, fire. So you don't want to set the building on fire in order to train people. And if you don't have a very realistic scenario as well, when you train people, they don't have the right level of retention. However, with virtual reality, you can actually use the replica of the building virtually and then simulate the right level of risk or hazards and use that for emergency preparedness training. Again, you could use virtual environments which are realistic using VR to help with risk assessment, to understand where there might be risk in a workplace or on a construction site. So this can be used in helping you design your safety or critical safety systems. You could use this for equipment operation. So just as pilots would normally train how to operate planes in a simulator, and then they can simulate different hazard or risk situations and how to navigate it. You could also use this to train workers on how they can operate equipment safely, so that when they actually go onto the site and situations arise, they'll be able to deal with it. There's so many other uses, how to properly use equipment, how to properly use personal protective equipment. These are all possibilities. So rather than doing it real, you can simulate it virtually. So you can see some of the examples here. We've got excavator simulators. You've got a simulator that can be used, to train on how to operate either a forklift, an excavator, or the like. So these are some of the application areas. There are a number of prototypes that have been developed. Tools already exist commercially, but how effective are these tools, and in which scenarios have they been used? So over here, I'll talk about a few projects that we've done. I realize we're running a bit out of time, so I might whisk through these ones a little bit quickly, but it's just to give you an example of how we have applied virtual reality in safety scenarios and what the outcomes were. Okay, so the first is this is a project that was sponsored by EU Erasmus Plus, so the EU Commission. So we did this across the UK, Poland, Spain, and Germany. So the project was about using virtual immersive reality safety training environments for robotized and automated construction sites. Why this? So increasingly on construction sites across the world, I'm not sure what the scenario in Malaysia is, but I'm sure it's very similar to the developments across the world. We're increasingly using automated systems, either on construction sites or in factories where we produce construction components and materials. And this market is expected to grow in the next sort of decade. So we're currently looking at a robotics market in construction of around 78 million, and it's projected to reach almost 300 million in the next sort of 10 to 15 years. So it's a growing market. However, when you use autonomous systems on construction sites, you can't completely eliminate construction workers, because the nature of construction is that it's labor intensive. So what we predict is that even when we use automated systems, so not only robots, but all sorts of automated equipment on construction sites, it's still going to be with human workers on the sites. Okay, so it increases the risk of having of human machine interaction. Okay, and a lot of fatal accidents happen as a result of human machine interaction, collisions with equipment. So with construction sites that would have autonomous equipment and robots, what would be the risk? Okay, so this is a scenario that you can't easily have physical replications of. So we found virtual reality to be a very good approach to trying to sort of simulate this. So this is an example of some of the risk that we identified are present in environments where you have both autonomous equipment as well as human beings. Control issues, there are mechanical failure issues, there are robot installation issues, but most importantly, human error, work design failure, procedural failure, environmental issues. And these ones are the ones that are most related to human machine interaction. So some of the research we've done is mainly to sort of understand those interactions a bit better, especially if you see up on the slide, you'd realize that drones, robot dogs, autonomous dumpers, autonomous excavators, these are already machines that are being used on site. However, current health and safety management systems did not necessarily preempt that we would be using robotics and autonomous systems in construction. So they are based on equipment that were not autonomous. So this research was to simulate these situations to see how construction workers perceive it and also what sort of risk emerge. So basically, that was the aim of the research, to investigate the associated risk of robotics and autonomous systems and its use within construction, and to see how virtual reality could be used to help manage this. This is an example of a scene from the virtual environment. So over here, we've tried to simulate the operation of a drone in adverse weather conditions. So you can see that virtually we have a construction site with all sorts of elements from dust and the like, and you've got a drone which is operating with different mechanical issues. So over here in the image earlier on, what you saw was the controller for the drone, showing you different indicators, and somewhere, I'm not sure you can see up there, well, is the drone. So this we simulated. So we have more or less like a simulator for operating drones on construction sites and putting different risks to it and seeing how an operator on a construction site would react to these risks. This is another example of an autonomous digger on a construction site, also with various types of risk on the construction site. So I wouldn't go into all of this video, but then if I move it along, you'd realize a number of scenarios. Already showed you the drone scenario. You have other scenarios with autonomous transport vehicles on construction sites. So again, we believe that we did successfully do, and we did use this more to understand people's perceptions of these risks, but also if we were to use it as a training tool, how would people sort of be able to manage it? Over here, some preliminary results you can see showed when we used the VR versus non-VR approaches to simulating risk on construction sites, when autonomous equipment are used consistently, using VR outperformed using non-VR. However, you can also see that there are specific areas of risk that VR didn't outperform non-VR as much, but there are other areas where it did. So it also tells you that it's not a silver bullet. It doesn't solve all of the problems in terms of safety training or simulating of risk. But in most cases, it outperforms other traditional ways of representing this. Another study we did was again, this was, so previously I used to be in UWE, so this was research that we did. And what we tried to do was to try to understand how visual attention measurement can improve safety training using immersive technology, specifically virtual reality. Again, on construction sites, there continues to be a lot of fatalities and a lot of accidents, and a lot of this is because of human factors, because people fail to recognize hazards, and a lot of these hazards visually are represented on site, but for some reason sometimes people still can't recognize them. Okay, so there might be safety warnings, but still people can't recognize them. So the aim of this research was actually to see whether or not it's possible to measure visual attention using eye tracking, especially when people are immersed in virtual reality training. So we developed a training tool using a gaming engine approach, as well as build information modeling. So we do the virtual site, we put it into a game, and then we integrate eye tracking technology into it. So this is an example of what it looks like. So over here, you can see on the left side, virtual training environment. On the right side, you can see that someone is looking in this site and trying to do a task or identify hazard, and we are extracting eye tracking data, which helps us to measure their visual attention. So what are they missing? What are the areas of interest? What will we want them to see? What is enabling them to see what they need to see in terms of safety warnings, and what is preventing them from seeing? So basically, that's what the research was about. Again, it's more or less still ongoing, but I'll share a bit of preliminary results. So this is what the results would look like at the end of someone going through that simulation. We are able to tell which places they looked at more, which places they didn't look at a lot, and so we're able to understand how looking at specific places that are important or that we consider areas of interest influence how much they understand risk on the site. So this would help us in designing construction sites a bit better, or understanding how individuals perceive construction sites, so that we're able to design better interventions. And then we have some results that showed that people who perform better in terms of understanding risk, a lot of it had to do with their experience. But also, what it also showed us is that with people with less experience, once we understand how inefficiently they are appraising sites of risk, then we are able to design even better systems for them. I won't go into the details of this, but we used machine learning in order to understand how the eye tracking and visual attention data could be used in predicting how well people will perform, or how, in terms of understanding and identifying risk in virtual construction scenarios. And we had some very promising results that when we measure people's eye, when we track people's eyes and visual attention data, this usually gives you high volumes of data through machine learning. We're able to predict specific patterns, which indicates one thing or the other. For example, whether or not they are likely to find risk, or they are missing a lot of risk and visual cues in the virtual simulation. So that relates to safety. Fundamentally, we've done these using immersive technology We've also, in our research, come across a lot of already commercially available tools for using immersive virtual reality, either for training construction workers or for risk assessment on construction sites, for example, using things such as digital twins or BIM models. And in terms of converting these into virtual simulations to use for either training or safety planning, generally what our research has showed us is that it is feasible, it is effective. For example, if you look at training, our research has showed usually maybe about 30 to 40% better in terms of knowledge retention when you use VR for training. In other places, they've quoted higher figures like 70 to 80%, but our figures have been more conservative because we think it's still not 100% effective as a technology, but it's very promising. Okay. So there are still areas that can be explored in terms of the use of these immersive technologies in the future. There's a lot for integrating AI and machine learning. It helps with personalized safety training, but we still need to develop it. It helps with user-centered design of systems, and also it could help us with augmented workers, so making workers a bit more capable by using additional technologies to enhance them. And immersive technologies are helping us to understand these scenarios a bit better. There are barriers such as technology maturity. So these devices, they are great, but they have their limitations. There's also problems around skills for developing these systems. So that brings me to the end of my lecture. Sorry for rushing through the end. But yeah, thank you very much.
Okay, thank you very much, Dr. Abdul-Majeed, for insightful presentation. We are now proceed with the maybe short Q&A session. Okay. Okay, one question from Muhammad Nazli. Okay, in the chat box, I read, given that Malaysia still benefit from relatively low cost labor in the construction industry, what could be the most effective approach to accelerate the adoption of technologies such as automation and immersive technology in construction?
Okay, I think that's a very, very good question. And I don't think it's peculiar to Malaysia. Even in the UK, construction is still highly labor intensive, despite the fact that we're talking a lot about robotics and its application and automation. So I think all across the world, it's labor intensive. I think the key thing is not about replacing workers on construction sites with these autonomous equipment and technologies, but it's about how we can enhance the workers. So, for example, how can we improve their productivity, or how can we make them work more safely? Yeah. So it's a scenario of using autonomous systems, robotics, so you can work more safely. So ordinarily, there are certain tasks that probably are just a bit too dangerous or health-wise not very healthy, like manual handling. So can you now use these autonomous systems to eliminate those types of tasks, but you don't completely eliminate, humans? So construction, I think, will continue to be labor intensive, just as in Malaysia. But I think maybe the question should be, how can we adopt these technologies to make work safer for these people who work in construction? And the good thing is there's a lot of developments in terms of technology. It's becoming cheaper, and so I do envision a Malaysian industry that adopts these more in the near future.
Okay, thank you, Doctor. Anyone? Okay, one more question, I think. Okay. Other example of successful public-private partnership in the UK that have accelerated immersive adoption in safety management. And okay.
Yeah, that's a very good question, actually. So in the UK, a lot of so I wouldn't call it private-public partnership, but there's a lot of healthy partnership between public institutions as well as private construction companies and technology developers. That's leading to the development of all sort of things. So what government does is it sets an agenda of where we want to be in terms of specific technologies. Then it provides research funding, which normally construction organizations and technology providers can access collaborate to develop tools. So even some of the research work that we're doing is sponsored through similar funding. So not only in the UK, for example, one of the work we did was EU Commission funded, so across Europe. So in that sense, I think it's a public-private partnership, but not in the sense of public PPPs in procurement, but there is some level of partnership to ensure that we are adopting these technologies. So in the UK, there's a system called Knowledge Transfer Partnership. So over here, universities collaborate with industry, with government funding to develop specific tools for industry. And there have been, as even in my current institution, a number of those, or at least one of those, that was based on immersive virtual reality. Yeah. And the company involved is actually a startup in immersive technology. So they're getting university research support in order to improve their offering of the technology with some government funding. So so there is that level of partnership in terms of promoting these technologies. And I am sure, Malaysia has similar structure in terms of an industry. So I'm not completely aware of what's happening in Malaysia, but I wouldn't be surprised that there might be similar things happening, or opportunities at least.
Okay, thank you, Doctor. We're actually right on time. Okay, thank you very much for to both our speaker for the insightful and engaging presentation. We truly appreciate the knowledge and perspective you have shared with us today. And I believe it's been a valuable learning experience for everyone. Thank you once again. Okay, we have another session at 8 o'clock with Prof. Michael Bum. If you are free, we can join by using Zoom link. Yeah, using Zoom link at 8 o'clock Malaysia. Okay, before we end, we snap a photo first. Everyone, please open your cam.
Oh.
All right. Anyone? Please open your cam. Start recording first.